Hi, my name is Dwight Dunn and welcome to Lesson 6. For Lesson 6, we're going to be continuing with the product rule. So we're going to pick up where we left off from Lesson 5. So to get started, let's jump into the first problem that we're going to be looking at right here. So the first problem that we're going to be looking at right here is the cube root of x times x squared plus 4. So what we're going to do here, we're going to try to differentiate this. Now the two functions that we have working with is the cube root of x, that's the first piece, and then we got x squared plus 4, which is the second piece. Now the cube root of x is not easy to work with as is. As of such, we're going to change that to something that is more manageable or more differentiation friendly. To do that, we recall that if I do the nth root of any number, let's use just a to be general right there, this is simply equal to a to 1 over n. So that's the situation there. Notice here, if I have 1 right here, this one goes on the top. Whatever number that is goes on the top. Whatever root that is goes at the bottom. So I have a to 1 over n. So I'm going to change x cube root of x to x to 1 over 3. So with that being our case now, this is what the expression becomes. Now from there, I can differentiate. So I'm going to write x to 1 over 3 first. Then I'm going to differentiate x squared plus 4. To differentiate x squared plus 4, we have x squared, which is going to give us, put the 2 in front, it's going to be 2, subtract 1, we're going to get x. And then differentiate 4, we're going to get 0. To continue with that, we're going to now write the last, then we're going to differentiate the first. Now to differentiate the first, let's look at that carefully. We have x to a third. So for that little piece here, let me put that in my little box, going to be 1 over 3 x to 1 over 3 minus 1. So this here is going to be 1 over 3 x to, this is 1/3 from 1, which is negative, that's going to give me negative 2/3. Now I have x 1 over 3 times x to negative 2/3. So from there, I can then move forward. I recognize that I'm going to expand the parentheses. I have x to a third times x to 1. So notice this is x to 1. Add in 1/3 plus 1 going to give me 4 over 3. So just remember 1/3 plus 1 is the same thing as 1 over 3 plus 3 over 3. Add in the numerators. My result going to give me 4 over 3. So that's going to be 4 over 3 for that piece right there. Now, if I look at the other piece right here, I'm going to have x squared over 3 to 2 over 3. Now, why is it 3 times x to 2 over 3 at the bottom? Let's check that carefully. I know for this piece right here, if I have 1 over 3 times, this is going to be 1 over x to 2 over 3. Now, if I recall, I remember that if I have a negative exponent, just recall x to negative m, this is going to be 1 over a to m. And because that is 1 over a to m, I simply can bring that down. If I bring that down, multiplying the numerators, that's going to give me 1 over 3 times x to 2 over 3. So that there is my expression. So that is why at the bottom I have 3 times x to 2 over 3. Now, as a single fraction, I realize here that I have 3x to 2 over 3. So what I would have to do is get the denominators to be the same. Now, to get the denominators to be the same, I realize that this is over 1. Because this is over 1 now, I'm going to have to multiply the top and the bottom times 3 times x to 2 over 3. To multiply the top and the bottom by that, the bottom obviously going to simply be 3 times x to 2 over 3. Then my top going to be 6x squared. Now, why is my top 6x squared? All I did there was multiply 2 to x to 4 over 3 times 3x to 2 over 3. Now, 2 times 3 going to be 6. That's why I get my 6 there. 4 plus 2 going to simply be 6. Once I add that, 6 divided by the common denominator right here. Remember, we're adding the exponents. We're going to simply be 4 plus 2, which is 6, common denominator, which is 3. So that's going to be 6 over 3 for the exponent. So that's what give me my 2 right there. So with that now, I'm going to rewrite x squared plus 4 in the top. So just remember here, I'm multiplying 2 times 2, which is going to give me 6 times x to 4 over 3 plus 2 over 3. Denominators are the same, so just add the top. So I'm going to get 6 over 3. So since once I have that, what I'm simply going to do now is add the tops. To add the tops, I have 6x squared, x squared plus 4. Adding those, I'm going to get 7x squared plus 4. Now let's back up 1 second. If I want to be a little bit fancy in terms of my mathematics, what I could do is write this as 7x squared plus 4 divided by 3. This right here would simply be the cube root of x squared. So this would be an alternative representation for that solution right there. All right, so let's keep it going with that. Let's look now at this last example here. I got 1 minus 4x cubed in one parentheses. In the second parentheses, I got 3x squared minus 5x plus 2. Now, again, I have two different functions. One in the first parentheses, one in the second parentheses. And I'm going to treat them as a product. And then I'm going to differentiate using the product rule. So I'm going to write the first, differentiate the last, plus the last, differentiate the first. So let's put it to action. So here I write the first, which is 1 minus 4x cubed, differentiate the last. So we got 2 times 3, which is going to give us 6, subtract 1, that's just 6x, minus 5x, differentiate that, I'm going to get minus 5. Differentiate 2, I'm going to get 0. Remember, differentiating a constant give us 0. So write the first, differentiate the last, plus the last, differentiate the first. Differentiating the first, that's 3 times 4, which is negative 12. Subtract 1 from 3, we got 2. Now, once we do this, life becomes very easy. We can just simply expand the parentheses. So we're going to expand 1 times everything first, which is going to give me 6x minus 5. Then I'm going to multiply 4x cubed times everything, which is minus 4x cubed times everything, negative 24x4 plus 20x cubed. So that completes the first expansion. Now I'm going to multiply this by everything. My result then going to give me negative 36x to the fourth plus 6x cubed minus 24x squared. So that is my expression. Once I have that, I can put all my like terms together. So my result going to yield the following. So notice here, I just put the like terms, put the 4's with the 4's. Then I put the 3 with the 3's. Then I put the squares with the squares. So we only have one negative 24 squared there. Then I have my plus 6x minus 5. Then that completes my problem. All right, see you in the next one. I hope you enjoy the lesson and hope you stick through to the end, because we're going to be addressing all the different differentiation techniques that is very useful to do all different types of problems for any calculus course that you're going to be doing in the future. All right, have a great day. Be safe.